Hello everyone, welcome to today's session. I'm excited to introduce our topic, CBSE Class 8 Science, focusing on force and pressure. This is a worksheet designed to help you understand these important concepts better. Over the course of this presentation, we'll explore key ideas, concepts, and practice questions related to force and pressure. So let's get started and make learning both fun and informative. Welcome to this worksheet for Class 8 Science Chapter 11, which is all about force and pressure. In this slide, we're focusing on the introduction and the contents of this chapter. As we go through, I'll highlight the key points and connect them to the bigger picture of understanding how forces and pressure affect our daily lives. This chapter is fundamental because it helps us understand the concepts behind why objects move or stay in place, and how pressure plays a role in various phenomena. So, keep these concepts in mind as we explore the details further. Let's start with the introduction. In this slide, I want to emphasize the importance of setting a strong foundation for our presentation. We'll be covering the key points thoroughly, but in a conversational way, so it feels engaging and natural. The goal is to highlight the most important concepts clearly and connect everything back to our overall theme. This way, you can see how each part fits into the bigger picture, making the entire presentation more cohesive and impactful. So, as we go through this, keep in mind how these introductory ideas set the stage for the rest of our discussion. Let's take a closer look at this slide. Here, we're emphasizing the importance of downloading the free PDF of the CBSE Class 8 Science Force and Pressure Worksheet. This resource is designed to help both students and teachers by providing printable worksheets that align with the latest syllabus and exam patterns. It's especially useful for Class 8 students to practice the questions and answers related to Chapter 11, which covers force and pressure. By working through these worksheets, students can strengthen their understanding of all key topics in this chapter. I also want to highlight that these PDFs are prepared by school teachers, ensuring they are accurate and relevant to current academic standards, including NCERT, CBSE, and KVS guidelines. Practicing these important problems daily, with solutions included, can really boost your confidence and improve performance in school exams and tests. So, I encourage everyone to download these free resources and make them a regular part of your study routine. Let's take a closer look at this worksheet for Class 8 Science Chapter 11, Force and Pressure. Here, you'll find several questions designed to help you understand and apply the concepts we've discussed so far. The key points to focus on include understanding the different types of forces, how pressure is calculated, and the real-life applications of these principles. This worksheet encourages you to think critically about how force and pressure work together in everyday situations, like walking, swimming, or even using a syringe. Remember, grasping these concepts is essential because they form the foundation for understanding many phenomena in physics. By working through these questions, you'll reinforce your learning and be better prepared for exams. Keep in mind the connection between force and pressure, how increasing force or decreasing the area over which it is applied affects the pressure exerted. This understanding is crucial for solving practical problems and understanding the behavior of objects around us. Hello everyone. Today, I want to talk about an important resource for Class 8 science students studying Chapter 11, Force and Pressure. You should refer to the printable worksheet available in PDF format. This worksheet is specifically designed to help you understand the key concepts of force and pressure in a clear and structured way. It includes various questions and answers that are very useful for your exam preparation. Using this worksheet can significantly boost your confidence and help you score better marks. It covers the most important points of the chapter, making it easier for you to revise and grasp the concepts thoroughly. By practicing with this test paper, you'll get familiar with the types of questions that may appear in your exams, enabling you to answer more accurately and efficiently. So, I highly recommend you to go through this worksheet carefully. It's a valuable tool to reinforce your learning and ensure you're well prepared for your upcoming exams. Remember, consistent practice is the key to success in science, and this resource is designed to support you in that journey. Let's go through some key concepts related to forces and pressure. First, when a rolling ball comes to a stop after some time, it's mainly due to the frictional force acting upon it. Friction opposes the motion and gradually reduces the ball's speed. Next, application of force causes changes in various properties. For example, force can change the shape of an object, which is a common application in everyday life. Now, let's talk about the force that acts upon another body without any connector. That's a contactless force, like magnetic or gravitational force. When it comes to liquids, pressure depends on two main factors: the height of the liquid column and the density of the liquid. The higher the column and the denser the liquid, the greater the pressure exerted. In the case of springs, the force used to stretch them is muscular force, which we exert ourselves. Moving on, to lift a 1 kilogram mass, which weighs about 10 newtons, we need a force of at least 10 newtons. When two forces are applied at the same point but in opposite directions, the net force is the difference of those forces, not the sum. Broad straps on shoulder bags help distribute weight evenly, making it easier and more comfortable to carry heavy loads. The scientist who invented a pump to extract air from a vessel was Robert Boyle, who contributed significantly to our understanding of pressure and vacuum. For measuring pressure in fluids, we use a device called a manometer. Pressure in solids depends on the force applied and the area over which the force is distributed. There are various types of forces, including contact forces like pushing or pulling objects, and non-contact forces such as gravity or magnetic forces. When air is filled in a container, it exerts pressure on the walls of the container. This pressure depends on the amount of air and temperature. Force generated by the movement of non-living materials is called muscular force, which is produced by muscles. The strength, or amount of force, is called its magnitude. The SI unit of pressure is the Pascal, which is equal to 1 Newton per square meter. If a man is standing behind a car, yes, he exerts a force on the car, even if it's just a small push. The weight of air in a column of the atmosphere over a certain area is quite large, around 1,000 kilograms for a column of height equal to the atmosphere. Force exerted by a magnet on another magnet is a non-contact force, illustrating magnetic attraction or repulsion. In liquids, the pressure exerted at different points depends on depth and density. Deeper points experience higher pressure. During a game of tug-of-war, if the rope doesn't move, it means both teams are pulling with equal force. A pressure exerted by air is called atmospheric pressure. It's the force per unit area exerted by air molecules. Finally, a force acting on a surface per unit area is called pressure, while a push or pull on an object is simply called force. And to conclude, one word that describes a force exerted by a magnet on another magnet is magnetic. Force per unit area is called pressure. When we talk about pressure, we're looking at how much force is applied over a specific area. This concept helps us understand things like why a sharp needle can pierce skin more easily than a blunt object. Force exerted by our muscles is called muscular force. This is the force we generate when we lift, push, or pull objects. It's essential because it allows us to perform everyday tasks and move things around. The strength of the force is expressed by its magnitude. In simple terms, how strong a force is depends on how much it pushes or pulls. We often measure this in units like newtons, which help us compare different forces accurately. An example of a non-contact force is gravity. Gravity is the force that pulls objects towards the earth without them touching each other. It's always acting at a distance, which makes it a non-contact force. The direction of the force of friction is always opposite to the direction of motion. So, whenever something moves or tries to move, friction works against it, trying to slow it down or stop it altogether. Applying force can change an object's shape, size, and state of motion. For example, pushing a ball makes it roll, and squeezing a sponge changes its shape temporarily. Force is a powerful tool to alter objects in many ways. The pressure exerted by air around us is known as atmospheric pressure. It's the force exerted by the weight of the air in the Earth's atmosphere. This pressure is what keeps us grounded and working behind the scenes in many natural processes. A force arises due to interaction or contact between two objects. When objects touch or act upon each other, forces are generated, like when you push a door or when two magnets attract or repel each other. So these key points highlight how forces and pressure are fundamental to understanding our physical world. They explain how objects move, change shape, and interact, which is at the heart of physics and our everyday experiences. Let's start with the first question on this slide. When porters place a round piece of cloth on their heads while carrying heavy loads, it's mainly to help distribute the weight evenly. This makes carrying heavy items more comfortable and reduces the strain on their necks and shoulders. It's a simple but effective technique that shows how practical solutions can improve physical effort. Moving on to the second point, it's easier to cut with a sharp knife than with a blunt one because a sharp knife has a cleaner, more precise edge. This requires less force to make a cut, and it also reduces the effort needed. Sharpening your tools isn't just about making things easier, it's about working more efficiently and safely. Next, consider what happens when two equal forces act in opposite directions on an object. The net force in this case is 0. That means the object stays in its current state, either at rest or moving at a constant speed, because the forces cancel each other out. Connecting these ideas back to our overall theme, we see how understanding the mechanics of forces and practical techniques can really make a difference in everyday life. Whether it's easing physical effort or improving efficiency, these concepts are all about applying science to real-world situations. Now let's take a look at 4 effects of force, along with an example for each. First, force can cause a change in the shape of an object. For example, when you press down on a sponge, it deforms, showing how force can alter an object's shape. Second, force can set an object in motion. Imagine pushing a shopping cart. The push is the force that makes it start moving. Third, force can stop or slow down an object. Think about applying the brakes while riding a bike. That's force at work slowing you down. Finally, force can change the direction of an object. For instance, hitting a ball with a bat changes its direction and makes it go where you want. These effects highlight how force is fundamental in everyday interactions and in understanding how things move and change around us. Let's take a closer look at some fundamental forces. First, we have the force that a charged body exerts on an uncharged body, causing attraction. This is a key concept in electrostatics, where charges interact over a distance. Next, there's the force that tends to slow objects down or prevent them from moving. This is what we call friction. Friction plays a crucial role in everyday life, from walking to driving. Lastly, we have the force exerted by all matter on all other matter. This universal force is gravity, which is responsible for keeping planets in orbit and objects grounded on Earth. Connecting these points, we see how different forces influence motion and interactions in our universe, helping us understand how everything around us behaves. Let's talk about pressure. Pressure is the force exerted on a surface divided by the area over which it acts. That's why shoulder bags are designed with broad straps instead of thin ones. When the strap is broad, the pressure on your shoulder is less because the force is spread over a larger area, making it more comfortable to carry heavy loads. Now, moving on to the question. The pull of the Earth is a force called gravity. That's what keeps us grounded and causes objects to fall when dropped. Next, have you wondered why the pillars holding up the metro train tracks have a broader base? Well, it's because the broader base distributes the weight more evenly, providing stability and preventing the pillars from toppling over. Think of it as a wide foundation for a tall building. Let's look at what influences the direction of a moving object. It depends on the force acting on it, which can change its speed or direction, but the key is understanding that force causes change. When we talk about a force, it cannot change the mass of an object. Mass remains constant regardless of the force applied. Now, if you apply a force over a smaller area, the pressure exerted increases. That's why sharp objects like nails or needles exert high pressure. They concentrate force over a tiny area. Finally, an example of a contact force is friction. Friction occurs when two surfaces slide against each other, like when you rub your hands together or walk on the ground. So, in summary, understanding pressure and forces helps us explain everyday phenomena, from carrying bags comfortably to the stability of structures and the behavior of moving objects. Let's discuss why Rahul mentioned there is no miracle in Baba Shyamdev's trick. Essentially, Baba Shyamdev lying on a bed of nails does not hurt him because of the distribution of pressure. The nails don't penetrate his skin because the pressure applied is spread over many nails, reducing the force on any single point. Now Bola was quite impressed by this miracle and shared it with Rahul. Rahul, however, understood that such tricks are based on scientific principles, not miracles. This leads us to an important point. There are no miracles in science, only natural laws. Moving on, let's explain why we do not feel the atmospheric pressure. The atmosphere exerts pressure on us from all sides, but our bodies are used to it and are balanced by internal pressure. Our skin and bodily fluids help equalize this pressure, so we don't feel it consciously. Next, consider liquids exerting equal pressure at the same depth. This is a key concept in fluid mechanics. Regardless of the shape of the container, liquids at the same depth exert the same pressure. This explains why water in different shaped containers pushes equally at the same level. Now let's talk about forces. When a ball rolls on the ground and eventually comes to rest, the force involved is friction. Friction opposes the motion and gradually stops the ball. Regarding the pressure exerted by a liquid at the bottom of a container, it depends on the height of the liquid column. The higher the column, the greater the pressure, a fundamental principle in understanding fluid pressure. Finally, let's briefly touch on different types of forces. Magnetic force is observed in magnets attracting or repelling each other. Gravitational force is what keeps us grounded and causes objects to fall. Electrostatic force involves the attraction or repulsion between charged particles. Frictional force opposes motion between surfaces in contact. To sum up, understanding these forces and pressure concepts helps us see the science behind everyday phenomena, from simple activities like rolling a ball to complex natural behaviors.